Hello everyone, my name is Rowley. Today I want to introduce the direct TPS sensor. Driving on the under-inflective tires is dangerous, according to the National Highway Traffic Safety Administration. Almost one-third of passengers' cars, light trucks, and SUVs are being driving with at least one under-inflected tire. Underinflection is one of the leading causes of tire failure. If tire pressure is too low, too much of the tire surface touches on the road, which increases friction. Increased friction can cause the tires to overheat, which can lead to tread separation and blowouts. Blowouts can put the drivers of the vehicle with the damaged tire as well as other drivers in harm's way. A blowout could cause the driver to lose control of his vehicle and crash. Depending on the severity of blowout, other drivers may swerve to avoid pieces of flying debris from blown tire and crash their vehicles. Still, tire pressure is not something that most non-commercial drivers frequently check and direct. Though tire manufacturers recommend that always checking air pressure once a month, many drivers never bother unless their tires appear low. That is a common misconception. Because of the life-threatening issue by tire failure, in response to the surge in accidents due to under-inflective tire, the U.S. government passed the transportation law. One of the outcomes is that most vehicles sold in the United States since 2007 include a tire pressure monitoring system of some kind. Not every TPMS works in the same way. The illumination of low tire pressure indicator represents the final step in the process of either an indirect TPMS or direct TPMS. In this video, we focus on the direct TPMS. Direct TPMS use pressure monitoring sensors within each tire that monitor specific pressure levels, not just wheel revolution data from the anti-lock brake system. The remote sensing module is one of the main components of direct TPMS. Also, the direct TPMS sensor is one of the main components of remote sensing module. Once mounted in the tire, the RSM is a standalone device. Its embedded intelligence must independently manage the sensor function, the measurement process, the RF transition, and the power management. The direct TPMS sensor's internal state machine manages 4 different modes. Standby. All analog and digital blocks are switched off except for an internal low-frequency oscillator that sends a wake-up pulse over an output pin to the controller periodically. Pressure measurement. The pressure cell and the capacitance to voltage converter are activated. Temperature measurement. The temperature cell and its conditioning block are activated. Rate. After passing through one of the 2 measurement modes, the measurement is stored in the sampling capacitor. The rate mode activated the converter and enabled the controller to rate the measurement seriously. The Motorola TPMS pressure sensor, one of the most famous TPMS sensor, which is CMOS based, a technology known for low current consumption and robustness. The standby mode draws lower than 0.5 microampere, and because the sensor is in model all the time, very low power consumption can be achieved. The pressure sensing cell is capacitive and requires a conversion stage. In addition to analog function, CMOS technology allows higher level of integration such as digital processing possibilities. Examples are the sensors built-in non-volatile memory that stores calibration, and a converter that allows serial measurement reading by the microcontroller. The next generation of TPMS will have the new and different set of requirements. Adding more sensors and components may not necessarily be the way to provide all these additional features. Combining different information sources could be the path. TPMS is surely destined to become more integrated into the vehicle architecture. Furthermore, the automotive industry is considering wireless links as an alternative to simplify the increasing complex of electronic harmonies. In addition, if these sensors are to be battery-powered, some very serious environmental issues regarding end-of-life battery recycling will be raised. Alternative batteryless solutions based on the inductive coupling are therefore being investigated. Its price should be much cheaper than now. This is my presentation. Thank you for listening.